Hello everyone. My name is Malika Aslanisan and I am a TA for this course, Numeric Linear Algebra. And we are in the week 11 of this course. And today we will be discussing some problems which will be helpful in solving the assignments. So, do you want to summarize what you have done in the week?
Yeah, mainly about the householder matrices, their applications, and your QR factorization, and some theorems on eigenvalues and QR methods. Mainly on householder matrices.
Yeah, because other topics we have done already also. QR, did we study QR decomposition in this course till
No, no.
now? No, only I think diagonalization we did, no?
Yeah,
Okay, so is my screen visible?
yeah.
Okay, then. So I went through the previous year assignment. So mostly the questions were related to household and matrices only. And now let us begin with the question. Okay. So have you gone through the assignments?
Yeah, some must I have done and some are still left.
Okay. So there is time for submission. No?
And then Wednesday it's time for submission.
Okay. 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 So the first question is, let H be a householder matrix defined by H is equal to I minus 2 W transpose, where W is a unit vector in Rn. Then which of the following property does not hold? Okay, so the first one is determinant of H is equal to minus 1 if X belongs to S perpendicular, then H of X, H into X is not equal to X. The third one is if X belongs to S, then H of X is minus X. And fourth is H is symmetric and orthogonal. So you all know that what H is. H is an orthogonal, like H is a householder matrix, and you know about the properties of H. So, according to you, which option should be correct?
Two, option two.
Okay. So yeah,
X is equal to X.
yeah. Basically, we know that the idea behind householder matrix is. Can you tell me what type of matrix is a householder matrix?
It's a symmetric orthogonal
Yeah,
matrix.
symmetric and orthogonal. But any further you want to tell? Any other property? Property, no. Any other speciality of H?
Specialty.
See, basically, we know that the orthogonal matrix can have determinant 1 or minus 1, right?
Yeah.
When
Yes.
when the determinant of the orthogonal matrix is 1, we say that it is a rotation matrix, right?
Yeah.
It rotates things. Like we have matrices such as cos, including cos and sine terms. We have done that before. They were rotation matrices. They used to rotate the vector. But you would have noticed that what H does basically, it reflects a vector, right? So here H is basically a reflection matrix. Like the basic idea behind H is that when we form H, you notice that we take a vector u, a vector v, right? And this is basically u minus v. Then the w we take is a perpendicular on it, okay? Right. So
Yeah.
what does that H matrix does? It basically rotates, reflects a vector. Like if we put x, it will give us minus x. Right? We have done that. The W which we are forming in this case, that is something like this. Okay. Perpendicular to this line. And all the vectors which are on this W, okay, which are in the span of this W, which I have denoted here as S perpendicular.
Generated.
When any vector x along this S perpendicular is taken, it will reflect it. It will give us minus x, not x. And if any vector is taken along this line, okay, perpendicular, or we can say along S, no, sorry, if we are
It's taking
taking,
perpendicular, it will give the same value.
when we are taking on perpendicular, it should give us the same. So the
Yeah.
perpendicular line is this, okay, this is our W and this is our perpendicular to it, okay. So if x is perpendicular to this W, then it should give the same vector, and if x is along this vector, it should give its reflection, it should be minus x. Okay, understood. So here also you can see that the first option is determinant of h is minus 1, that is correct. But x, if belonging to S perpendicular, then h of x should be what? It should be equal to x, right? But
Yeah.
here it's shown that it's not equal to x. So this option is incorrect. Then the third one, x belonging to S, then h of x is minus x. Yeah, that is because it is reflecting. It is a reflecting matrix, it will reflect x. And then h is symmetric and orthogonal. That you already know. Okay.
Yeah.
So coming to question number 2, let h is equal to I minus 2 W W transpose be a householder matrix where W is equal to 0.8 minus 0.2 minus 0.4, 0.4. Okay. Then what is the value of h of x where x is equal to minus 1, 5, 7 and minus 9. So how will we solve this question? Have you
Yeah.
done?
W is given, right? So it is straightforward. That
Yeah, you can
in
simply form.
five each.
Yeah, you can simply form H matrix and then calculate.
Yeah.
So can you do it now and tell me? Anyone got answer?
Householder matrix is 0.28, something like that.
You can directly do hx and tell me the value of that. Multiply it with x and tell me.
Madam, it is 12.12,
Yeah,
12.12, 1.72, 0.44, minus 2.4.
yeah, that is the correct one. So did you do it in the similar way? Calculated h then multiplied with x?
Yes, first omega omega transpose, then h, then hx.
Okay. See, there is that one method is there already which you are doing, that you multiply W with W transpose, then form the H matrix, then multiply with X. But see, it is a bit lengthy procedure because W into W transpose will give you a 4 cross 4 matrix, right? After
Yes.
yeah, and after multiplying with X, so it is a bit computationally lengthy. So I have done it in another method, but it you can do it in the same way as you had done. I will show you a different method. Okay. So we know that, so we have some vector x given, right? Now they are telling, yeah, w you have been given already. There is a vector x and you have to form a householder matrix and then find the value of hx. But we already know that this x will have two components, right? One perpendicular to w. It will be what? Say it's x n, okay? I'll call this xn. And one will be parallel to W, and let me call it, say, XS. Okay, write
Yes.
it here. It is XS. Okay, so this one, yeah. So this one is XS and this one is XN. Now we know that a property that HX can be written as what? H of XS plus XN, right?
Okay, okay.
And we know that it will be equal to H of XS plus H of XN, correct? Now, when
Minus
hx,
6x.
when h operates on xs, it will do what? It will be minus
Minus,
xs.
minus,
But when h operates on xn, it will remain the same. So it will be plus
same,
xn, correct?
xn.
So I can write it as xn plus xn minus xs, right? Now x has been already given to us. So we can write, yeah. So we can find, firstly, we will find excess. Okay. Excess will be what? It will be the perpendicular component of x. And we know how to find perpendicular component of x. It's simply the dot product, right? From the dot product, we will find the excess component. And after finding the excess component, we know that hx is equal to what? Xn minus xs. So we will simply do that. And we'll find the value. So here I'll write it. Let xs denotes the component of x in the in direction of w. Then xs will be what? it will be x transpose w into w, right? The direction into the magnitude. From dot product we'll get magnitude. It will be equal to minus 0.8 minus 1, okay, minus 2.8 minus 3.6 into w vector. So the w vector is 0.8 minus 0.2 minus 0.4 and 0.4, okay. So this will come a number, and when you multiply it, it will be minus 6.56, 1.64, 3.28 and minus 3.28. Okay. Now after finding this, h x is equal to xn minus xs. Now, okay, okay. So it will be now how will you get xn? Xn is simply x minus xs, right? Xn can be written as x minus xs and minus xs. So it will be what? X minus 2xs. Now x has been given in the question. It is what? Minus 1, 5, 7 and minus 9. So I'll write it here, minus 1, 5, 7 and minus 9. Then minus twice xs. Xs is what? Minus 6.56, 1.64, 3.28 and minus 3.28. So when you calculate this, it is coming out to be 12.12, okay, 1.72, 0.44 and the last one is equal to minus 2.2. Okay.
Okay.
So this is one method you can do if you find the matrix is too big. This method you can.
It's a simple
Till
method.
here. Get my calculator. So should we move further?
Okay.
If you are noting it out, you can. So question number 3 is, it's basically a simple question, property based only. Let V is equal to R3R be a three-dimensional real vector space. Okay, it is capital V here. And H is equal to I minus W into W transpose. Sorry, I minus 2I is W into W transpose. Be a householder matrix where W is a unit vector in R3 and let U is equal to minus 1 by root 2, 0, minus 1 by root 2 transpose. Okay, these are the three entries. And V is equal to minus 1 by root 3, 1 by root 3 and minus 1 by root 3 transpose. Be any two distinct vectors in R3 if W is equal to U minus V upon norm of U minus V, then Basically, it is a multiple choice question, but then I will ask you simply to find UH. What will be the value of UH?
HU equal to V.
Huh?
HU equal to V. I think
Yeah,
some
HU will
theorem.
be V. So there was nothing in this question. Basically, they have just given the magnitude in this form. HU is equal to, they have given many options, HV and in HV and HU, and HU has been given as 5674, 0.5674, and minus 0.5674. Okay, so this is basically a like property based question. If you forget the properties, like in exams, you will think of solving it like completely. So you don't have to do that. Remember the properties, then you can simply do like these questions in simple way. Okay. So these are the assignment questions only. So now next question is, let V is equal to R2. Okay. Be a 2D real vector space and again H is equal to I minus 2W into W transpose. Be a householder matrix where W is a unit vector in R square and X is equal to 1 and 1 belongs to R square such that Hx is equal to minus 1.41420. Then find H. So here you have been given Hx and you had to find H. Okay, so in the previous question, W was given and from W we could you calculate H, right? And then we could find Hx. But here you have been given the value of Hx and X. So, and you have to find H. How do you do this type of question? How do you find H? You have done similar questions in assignments, right? Am I audible?
Yes, yes.
Huh. So can you give me the overview how to do this type of question? How do we find H here? See, there are two ways to do this. Okay. We know that since the entries here are only 2, H is going to be a 2 cross 2 matrix. Then we write H such that, okay, we write H in such a way that it is real, orthogonal and symmetric matrix. Okay. After that, we put Hx is equal to this value. Then we will get two equations and two unknowns and we solve that. So that is a basic method. Okay. I'll write that down. Okay. We define say H is equal to A, B, B and minus A. Okay. Why? Because we know that it is orthogonal matrix, so the magnitude should be equal to 1. So we will write under root of A square plus B square is 1. The determinant should be equal to minus 1. That property we use. And other than that, it should be a symmetric matrix. That's why I put B and B here. Okay. Now when we equate this Hx with this minus 1.41420, we get what? We get two equations, A, B, B minus A into X is as 1 and 1 It is minus 1.4142 and 0. Right. Here we got what? A plus B is equal to minus 1.4142 and B minus A is equal to 0. So A is equal to B, right? So from here 2A putting in 1 is equal to minus 1.4142, which implies A is equal to minus 1.4142 divided by 2, and this is coming out to be minus 0.707. Okay, now A we have gotten, then we can write B and minus A. So this is basic method, but we will follow the standard procedure to do this. Okay, we know that vector has been given. So to form H, basically what we need is, we need this W.
But if the more, this will be difficult, right? 3 by 3 and all it will come means it will be this method will be difficult.
Yeah, this method will be difficult. That's why I told you, yeah, you can follow the basic the actual method, standard method. Okay, you have to choose according to the type of question you're getting, what is easy for you. So when you get the base in the standard procedure, what you will do is that to form the H matrix, we need what? We need the value of W, which has not been given. So how do we calculate W? From X, we form a U vector, right? From that U, we form a V, and then we find the W. And after that, we can get the H matrix, and then we can easily find HX. So we will do in that way also. Firstly, we have been given X is equal to 1 and 1. Now, what is the value of U? We know that U is nothing but the normalized value of X. So we'll write it as X upon norm of X. It will be 1 over root 2 into 1 and 1. So U will be 1 upon root 2 and 1 upon root. Okay. Now from U, we know what is V.
Sign up.
Sign of the first entry and the rest are 0. So sign minus of sign of the first entry. So sign of first entry is 1. It is plus, so it's plus 1. So we will write it as minus 1. Okay, because we have to take a minus. And others are 0. So our V matrix is this. Now what is W? W is U minus V upon norm of U minus V. Can you quickly tell me what you are getting here? U minus V will be what? 1 by root 2 minus 1. Then second entry 1 by root 2. Okay. Which is equal to 1.7071, and 1 by root 2 is 0.7071. And this whole thing divided by the magnitude of U minus V. U minus V is what? This thing. 1 plus 7071 square plus 0.7071 square. Tell me what is the value of W now?
This 1 by root 2 minus 1 is 1.7. Is it correct? First thing.
It's 1 by root 2 minus of minus 1, sorry. So it is
That's one. Yeah.
plus 1. Okay. It will be U minus V, that will be 1 by root 2 minus of minus 1, that will be plus. Okay.
Yeah. Sinus.
So what is the first entry of W? 1.7071 divided by this magnitude. Won't take too much time. It's simple. It's coming out to be 0.9238. Okay. And the second entry is similarly coming out to be 0.3827. Are you getting the same? Are you getting the same?
I get the same answer.
Huh?
Yes, mom, get the same for W.
Okay, okay. Then find what is I minus 2 W transport. Quickly. It will be a 2 cross 2 matrix 1 0 0 1 minus 2 into W is 0.9238, 0.3827 into 0.9238 and 0.3827. Quickly calculate this and tell me what you are getting.
H is minus 0.7039.
What?
H value minus 0.7039. Correct.
Yeah. So you're close. Matlab, I have done it. It is coming out to be minus 0.07071. The second entry is minus 0.7071. The third one is minus 0.7071. And last one is 0.7071. Okay.
Okay.
So this is what I am getting. So yeah. Now I'll give you a similar question. Okay, it was also an assignment. You try to do it, then we will discuss the solution. Let again H is equal to I minus 2 W transpose. But you guys should be doing it a bit faster, because that is how you will manage time in exams. Should not give much time. So work on your speed also and accuracy also. So here again, X has been given as this. Okay. and hx has been given as 7.3485000 transpose. Okay, then find h. Again you have to follow the same procedure. Just tell me the answers you are getting at every step. What the x you are getting, then tell me u, v, you what is u minus v, and then finally what is your w, and then what is your h. What will be the value of u? X by norm of x. So x is already there. Norm of x is coming out to be under root of what? 25 plus 16 plus 9 plus 4. Okay. It will be 7.3485 into x is minus 4, minus 5, 4, 3 and 2. What is the value of u? 5 divided by 7.3485 will be minus 0.6804. Okay. The second value is 4 divided by 7.34. What is it? Coming out to be 0.5443, right? Third one will be 0.4082. What is the last one? 0.2721. Okay. Now, so what will be v? V is firstly it will be plus 1, right?
One.
Because
One.
we have a minus entry, so it will be 1, 0, 0,
Plus
0. Now what is u minus v? U minus v will be 1 minus 1.6080. Okay, sorry, it's 6 minus 1.6804. Rest of the entries will remain same with a minus sign. So and what is w? U minus v upon norm of u minus v. Tell me what is this matrix coming out. Norm of u minus v is nothing but you have to take the under root of these things. Okay. And divide each element with it. Tell me what is the first entry? It is minus 0.9166. Second will be 0.2969. Third one is 0.2227. And the last one will be what? 0.2721 divided by magnitude will be 0.1484. Okay, you are getting the same?
Almost same.
Huh?
Almost same.
Okay. So what will be H matrix? H will be I minus twice W into W transpose. So this you can quickly do and tell me what you are getting. calculated the final matrix, I'll write it down and you keep on doing yours and I'll cross check it with you. So minus 0.6805, 0.5443, third one is 0.4082, and last one is 0.2722. The second row is 0.5443, 0.28237, minus 0.1322, minus 0.0881. Then the third row is 0.4082, minus 0.1322, 0.9008, minus 0.0661. The last one is 0.2721, minus 0.0881, minus 0.0661, and 0.9559. Are you getting the same?
First column I'm getting, others I'm trying on.
Yeah. Try and complete it.
I'm getting the same.
Almost getting, ma'am.
Okay, you are getting the same matrix.
Yeah.
So should we move to the next question? So the question is, let A is equal to 4, 3, 2, minus 3, minus 2, and minus 3. Okay, and 3, 2, 4. Then which of the following is true about matrix A. Okay. First one is eigen values of A are 5, 2, minus 1. Second is if 2 is an eigenvalue, so of A, then the corresponding eigenvector is 1, 0, 3 transpose. Third one is A has complex eigenvalues. And the last is A is diagonizable. Since it is related to eigenvalues, you first will find what? Eigenvalues of A. So A minus lambda I determinant is equal to 0. So it will be what? Determinant of 4 minus lambda, 3, 2, minus 3, minus 2 minus lambda, minus 3, 3, 2 and 4 is equal to 0. Can you quickly find the eigenvalues?
4 minus lambda.
4 minus?
Last line, last.
Oh yeah, sorry. Wait, 4 minus lambda.
First option is
It will
incorrect.
be minus 2 minus lambda into 4 minus lambda. Okay. Plus 3 lambda plus and the last one is 2 into minus 6 minus will be plus 6 plus lambda is equal to 0. Okay. Simplified further. 4 2s are 8 plus lambda square. Okay. Then minus 4 lambda and minus 2 lambda plus 2 lambda plus 6. Then minus 3 into 3 lambda minus 3 and minus 2 into lambda is equal to 0. So it will be 4 minus lambda into lambda square plus 2 lambda plus minus 2 minus 9 lambda plus 9 minus 2 lambda is equal to 0. So what is the cubic equation you are getting? 4 lambda square plus 4 2s are 8 lambda minus 8. Okay. Then minus lambda cube minus 2 lambda square plus 2 lambda minus 9 lambda plus 9 minus 2 lambda is equal to 0. This will go, it will be lambda cube, then it will be 4 lambda square minus 2 lambda square, so it will be minus 2 lambda square on the other side. Then it is minus lambda, it will be plus lambda, then 8 plus 9 is equal to minus 1. Okay. Is the equation this? And when you find the values of lambda,
What is the matrix?
it is coming out to
What
be,
is the
Lambda
matrix?
is
huh?
Madam, this is correct. The characters.
Sorry, you're getting different
Ma'am, once show the matrix, ma'am.
matrix
Please
again.
enter it.
The matrix was this, no? 4, 3, 2.
Ma'am, is the characteristic equation is correct?
Yeah, you're getting different.
Characteristic lambda cube minus 6 lambda square.
Okay, you're getting lambda cube. Tell me the
Because
eigenvalues you're getting.
actually the second entry is a trace of the matrix. So here the trace is 6 only.
Okay, you're telling it is the trace of the matrix.
It
So I'm
is
not.
6.
Okay,
It is 6. So that is the coefficient of lambda squared here.
okay, you're telling it. Okay, okay, coefficient of lambda square, right? Then I
Um,
might have made a mistake for 8
somewhere it is
minus.
a mistake, I think.
Yeah.
There is a mistake in between.
So, did you get the characteristic equation?
I that is lambda minus 6 lambda square
You're not audible.
plus 9 lambda minus 1. Lambda cube minus 6 lambda square plus 9 lambda minus 1.
Lambda cube minus 6 lambda square plus 9 lambda minus 1.
Minus 1.
Okay, let
Yes.
me check it once. Then I might have made some mistake. Hmm, it is 1. What are the eigenvalues you're getting? 9 and
Actually, the eigenvalue is the decimal one.
okay. So, yeah, I think I might have made some mistake. You can check that. This will be the characteristic equation because the eigenvalues are coming out to be correct. Okay. Now lambda is coming out to be 0.1206 and
Yes.
lambda 2 is coming out to be 3.5320, right? And the third
Yes.
lambda is coming out to be 2.347, right?
Yes. Yes.
Yes.
Yes.
Now from here you can see that option 2 and 3 and 4 is sorry 1, 2 and 3 are gone, right? Now coming to the fourth option, A is diagonalizable. Since all the three elements are distinct, we know that it is diagonally diagonalizable. Why? Because from three different eigenvalues, we are getting three linearly independent eigenvectors, right? And that was the condition for diagonalizing matrix, and you know how we can form that, right? Simply P, we form the P matrix, then P A P inverse. Okay. P was the matrix which we get from the eigenvectors of the matrix A. So now let's move to the last question. Okay. Use householder matrices to find the QR factorization of matrix A. Okay. And A is equal to 6 minus 7, 3 3, minus 5, 8, 3, 8, 9, 7, minus 5, and this is also minus 5, and the last row is minus 8, minus 3, 7, and 4. So, using householder this matrices, how do we find the QR factorization or QR decomposition? Can you tell me the basic procedure, what you have understood? Anyone of you? What is the basic idea of for QR factorization using householder matrices? We know that any matrix A can be written as what? QR, right? Where Q is an orthogonal matrix and R is an upper triangular matrix. Okay. So what we do in this method is that we know that what we did when we formed the householder matrix, we had a vector, and corresponding to that vector we calculated the householder matrix. Okay, here also in A we can conclude that, let's say all the columns of A are different vectors, then for each vector, say this is C1, column 1, column 2, column 3, column 4, then we form H1 matrix corresponding to each of them. Okay. Now this procedure gets lengthy on paper. I'll show you on MATLAB. That way I think you will understand better. Is it fine?
Okay.
Okay. Have you done any question like this in your assignment? If there is any question like this in your assignment. Are there any questions in which you have to do QR factorization of any 3 cross 3 or 4?
One question is there.
So have
Last.
you done it?
Oh, full is not completed, ma'am. So I am doing only.
Okay, no problem. I think we'll do it on MATLAB, that we will
There is no
understand better.
question from
Huh?
QR. There is no question from QR decomposition in
There is no
assignment.
question in assignment.
Last question.
That is also householders only.
That only one column and one row we have to find.
Ah, that is also householders only.
Oh, okay.
From
But in the
householders.
this question is from previous year assignment. I think there were 1 or 2 questions. In this question you had to find Q matrix, and another question was there in which you had to find R matrix. So I think I will show you this one anyway. Okay. So is my screen visible? Is my screen visible?
No, for me it is not. Just some scrolling is happening.
Okay.
Maybe that wavelength, that bandwidth issues may be there.
Okay, let me turn off my camera. Now, still you're not getting it?
Kavita ma'am is getting?
Actually, it is preparing, buffering only.
Is buffering only?
Now
Yes,
it's
yes.
there. Now it's some. Yeah.
Okay.
Next MATLAB opening.
Okay, so let me first write the matrix. Okay, uh, I s- wait a second. The matrix A. So matrix A is what? 6 minus 7, 3, 3. Right. The second row is minus 5, minus 7, minus 3, and minus minus 5, 8, 3, 8. The third row is 9. Correct me if I'm doing anything wrong, okay? Minus 5, minus 5. And the last row is what? Minus 8, minus 3, 7, and 4. Okay? Is our A matrix correct?
The second row it is minus 5 or
It is minus 5 only. Yeah, minus 5, 8, 3, 8, 9, 7, minus 5, minus 5, minus 8, minus 3, 7, 4. Okay? So this is correct.
no, the
Now,
here second row is 5, isn't it? It's not clearly visible.
oh, I have.
Second row first element is 5
No,
you're
no,
written.
no, it is minus 5 I have written. I think there is some like network issue, but it is minus 5. Okay?
Okay, okay, then it's okay.
Okay. So what we do, what our first step is, we will first take the what? First column of A, right? So the first column will be what? A, uh,
One, one,
comma 1. Okay.
no,
Okay.
mm,
So now that we have taken the first column of A, we form U1. Okay. U1 will be what? C1 upon
norm of C.
norm of C1. Right.
Yeah.
Norm of C1. Now we got U1 also. What is our next step? We will write
B,
V1.
B1
V1 we have to write on our own
minus
only. Okay. V1 will be what?
minus 1, 0, 0,
Minus 1,
0, 0,
0, 0.
0.
I can write it like this. Minus 1, 0, 0, and 0. Okay. Now we have got. Now what we write is next W1. Right. So W1 will be what?
U1 minus
U1
V1
minus V1 upon
by norm of
norm of
U1 minus V1.
U1 minus V1. So for the first column, we have gotten this. Now what we will write? We will write the
H1
H1 matrix. Okay. What will be the H1 matrix? It will be
I of
I of 4, right? Because it's a 4 cross 4 matrix. I of 4
minus 2
minus
into
twice W
1
W1 into
star
W1
W
transpose.
trans.
W1 prime.
Trans.
Okay. Uh-huh. Okay. So this is basically our H1. Now what is the next step?
H2 we have to
No,
find.
first we will find A1.
Okay.
A1 will be what? A1 will be H1 into A. After getting A1, then we will find C2, again U2, V2, W2, then we will find H2 prime. Like we will keep continuing till we get H1, basically H2 and H3. Finally, we will multiply all three of them and that will be our Q matrix, right? So now for finding H2, basically our idea is that we are here taking the first this first column and we try to make all the like apart from the first entry, all the down we try to make it 0. Now in second case also, we the diagonal entry we want to keep, and below that we want to make 0. So we will not take this 7 element here. Okay, this minus 7 we won't take. We will take from 8, 7, 3. And then we move on next. Here we will take only minus 5 and 7.
Yes, yes.
That is how we proceed. Okay. Now first we will form A1. Okay. So A1 will be what? H1 into A. Now, as I said, in see here, A1 you have gotten, you have this is also 0, this is also 0, this is also 0. Only the first entry is there. Here in the second row, again your purpose is that this entry should be there and the lower entry should be what? 0
Zeros.
in this case. So that is why we again follow this procedure. We take which column? C2 column. And here what will be C2? C2 will be equal to A1. But here we will start from what? Because we have to take the second row only. We don't have, sorry, we have to take the second column but from second row.
Second.
We have to ignore the first entry. So I will take it from 2 to end. Okay, rows from 2 to 2, 3, 4. Okay, 2 to end I am taking. And the column is what? Column number 2. Right? Understood this step?
Yes, yes.
Why I am writing this? I want to take only the 3 entries, last 3 entries, 6, 9 and minus 5. So I will take it from 2 to end and that of second column. So yeah, this I am getting. Now what will be the U2 here?
C2 by norm of C.
Yeah, C2 divided by norm of C2. Okay. Now U2 I have gotten. What will be my V2 here? My V2 will be, first is sign of first one, that is 1, and taking negative of that it will be minus 1, 0, 0. Right?
Yeah.
Now again calculating W2. What will be my W2?
U2 minus V2 by norm of
Yeah.
U2 minus.
U2 minus V2 upon norm of U2 minus V2. Okay. This is my W2. Now corresponding to W2, I will calculate what? My H prime.
H2.
Okay. So H2 prime, H2 prime will be what? It will be I
I
of 3,
minus I
right?
of 3
Because this is
minus
a 3 cross 3 matrix. Here we have only 3
Three.
entries, so it will be a 3 cross 3 matrix. So minus
2 into
W2
W2 into W2
into
transpose.
W2 prime or transpose. Okay. Oh. Okay.
Mm.
This
Then
one
we
is my
H2.
H2 prime. Now what will be my H2? Because our H2 should be 4 cross 4.
Yeah.
We calculated it for it as 3 cross 3 because we had to take from the second entry of second column. But to make it 4 cross 4, we know that first it is going to be identity here, then 0, and then this will be there, right? So I will write H2 as that my first column is 1, 1, 0, 0, 0, right? This will be my first row. Now in my second rows, I will
First.
write zeros. Okay, zeros from what? 3, comma 1. Okay, and then H2 prime.
Right.
So basically what this command is, first row I have written 1, 0, 0, 0. Then here zeros from all three rows and first column. So zeros in all 3 rows and first column, it will form a block here. Now and my this remaining block will be what? H2 prime. Okay. So from my this command I wrote my H2. Now from
Then we-
H2 again I will write what? A2?
8.
A2 will be what? H2 into A1. Okay. We have to go till H3. Now this is my A2. In A2, now see again this, look at this column.
Then
Minus
third
14 is there,
column
other
now.
are zeros. Here also my entry is 13 and first entry is there, second entry is there, other bottom are 0. Now I will take this row, okay. Now here, sorry, this column I will take and I will focus from here, okay. So I will try to keep this 2.3, this one entry should be there. Below it, everything should be 0. So I will take the C3 column, okay. But from where?
Third column, last row element.
Yeah. So it will be all 3 rows till end. That is only one row. Sorry, that is 3 and 4, okay. Of which column? Third column, okay. Uh-huh. So this is my C3 now. Now from my C3, what will my U3 be equal to?
C3 by norm of
C3 by norm of
C3.
C3 by norm of C3. Okay. This was not SSD correct. Yeah. So U3 again I got. Now my V3 will be what? V3 I have to define on my own. So it will be 1 and 0, right? Now what will be my W3?
U3 minus
U3
V3
minus
by
V3.
norm of U3 minus V3
U3 minus V3
by norm of U3 minus
divided by norm of U3 minus V3. Okay. So this is my W3. Now from W3, what will I calculate? H3 prime, right? H3,
oh,
H3 prime.
now H3
Huh?
prime, history prime. Yeah.
H3 prime, no? So it will be
Yeah.
what? Identity 2? Yes?
Of 2. Of 2.
What is happening? Identity 2 minus W3.
2 times
W3. Oh yeah, twice.
2.
Will be twice W3 star W3 transpose. Right?
Yeah. 2.
O2 into, wait a second. W3 into W3. Okay. So this is our H3 prime. Now from here, what will be my H3?
Maybe 1 0 0.
Now here our identity will be 2, a 2 cross 2 matrix. Okay.
Yeah.
Let me write it first, then I'll make you understand. It will be identity 2. Then next to that will be zeros. Okay. Zeros from what? Sec 2, comma 2. Okay. And next to this block will be again my zeros 2, comma 2 and H3
H3 prime.
prime. Okay. So basically this thing is here that my first block will be identity matrix 2 cross 2. Next to that will be the both the rows from for both the columns as 0 0. Okay, for 2 columns and 2 rows 0 0 0. Now in the second, my this block will be again 0 0 0 0 and here will be my H3 prime. So this is my H3. Now finally we have gotten all. So what we can write, Q equal to H1 multiplied with H1 multiplied with H2 multiplied with H3. Okay. So this will be my Q matrix. Okay. Understood till here? Understood? Or do you have any
This is
doubts in any
three.
step?
That X3, that second car.
The second one?
No, no, no. Okay, so okay.
Understood? Okay. So now we have to find the R. We know that A is equal to QR. So if I am finding R, what will it be? Q inverse into A, right? And Q is an orthogonal matrix, so we will write Q transpose into A. So here I can find R simply as what? Q
To
transpose
transpose.
into A. So basically, we are doing it this way. Okay. This is a lengthy procedure, but even if it comes in exams, you have to follow the same procedure. All these calculations you have to do by hand. So I am not sure if these how lengthy questions will be there, but yeah, this is the standard procedure of doing it. You can note down the commands, or I will share this also in the notes. Okay.
But the MATLAB they won't provide. No, we have to
No,
do
no,
by
MATLAB
hand.
they won't provide, but the steps are the same, na. I did it
Yeah,
so that I can make the computation easy, because if we do it in class, this calculation will take so much time, and there is no
yeah,
other
yeah.
procedure. You have to do it in this way only. The steps are all the same. You find U1, then V1, then W1, then H1, then you find A1, then from A1 you take second column and you find C2, U2, V2, and this is how you proceed with this thing. Okay.
Okay.
So I think this much is sufficient for today. Okay. I think all topics have been touched.
Any other extra questions and that also can give it has model questions or something. Now,
Okay.
by the next week classes will be over. No.
Hmm. So you want me to discuss questions or give you assignments which you can practice on your own?
Yeah, that is also good only.
What? You want for whom?
Yeah, some questions, some extra questions are there. You can try.
Okay, so the next session is on Sunday, na? That
Yeah.
time I will collect some problems on the whole
Yes.
numerical
Yes.
linear algebra you have done till
Yeah.
now. I'll
Okay.
share that with you, okay? Or if
Okay.
not possible, I will upload it directly to the folder. You have the access to
Oh,
the
okay.
folder,
Okay.
na? There I will
Okay.
upload, then you can practice that on your own, okay?
Okay. Okay.
So any topic which remain untouched, because I told you I just go through the topics and the assignment, I see which questions they have shown. I'll
Okay.
I solve them. So is there
Oh,
any topic you want question on during this week's content, or everything was covered? Now
this week
next,
everything is covered.
yeah, next I think there was QR factorization, but that is also again lengthy, right? You write A equal to QR, then you find
Yeah.
RE, then again do the QR decomposition. So that is a lengthy iterative process. I don't think that any question would come from that, but still for understanding, you should do that. And in assignment also there was not any question related to that.
Yeah.
Okay.
Okay.
So I will end the session here. I will, if I get
Okay.
the chance, I will upload during this week only some questions. Otherwise, in the next session, I will provide you. Okay?
Okay. Okay.
Okay, okay. Chalo, I'll end the
Okay.
session.
Okay.